what we can now do is try and think about ways of improving the algorithm. So that definitely works, but what we need to do is then sort of think about, are there ways we could do this better? So if I take the cards back in again and we mix them about a bit perhaps, and then give them back out and keep them hidden. So again, we've no idea. If we're going to do bubble sort, then we've got to do the same number of passes again to get them in the right order. Now, the thing to realise is each time I do a pass, I take the biggest value with me. So wherever I find it, whether I find it in the first position or the middle or the last position, whenever I get to the biggest value, and even the biggest value I've found so far, that's the thing that carries on moving with me. So if we look at the first two, let's sort of do the beginning of this. The biggest value of those two is 30, so that swaps, they're in the wrong order, so we swap, and then I move on, and I'm taking the biggest value with me, leaving smaller values behind. And then I do the same again, I compare the next two, and whichever is the biggest of the two, I swap them, and that bigger one goes with me. So swap positions, and again, smaller values go behind, and hide yours again. And now I'm comparing these two, and so turn the cards, and I'm going to take the biggest value with me, so swap positions. And I get to this point, and turn the values over again. And now I'm going to compare the next two, and again, I swap them, I take the biggest value with me. So the thing that we see there, so turn them back again, I've always taken the biggest value with me. So what can I be guaranteed of when I get to this end of the array? I'm guaranteed that that position is holding the largest value so far. And because I've done a whole scan of the array, it's guaranteed that is holding the biggest value. So what I know is I'm never going to move that again. So there is no point swapping or even checking earlier ones. I know I'm never going to swap them again, so there's no point even checking it. So I can kind of almost turn that one over. I know that's in the right position. I never have to worry about it again. And what I need to do now is do the next pass, but essentially I don't have to waste time going all the way to the end. I know that last position's right. I can now pretend I've got an array of size 4 that's one less and just sort that. So this time I do a comparison, and they're in the wrong order. I take the biggest value with me and hide the values again, and then I do the next comparison, and I take the biggest value with me and hide the values again and turn them over, and I take the biggest value with me, and I don't need to go any further because I know she's in the right position. I can leave her alone, but actually I've taken the biggest value with me again, so I now know he's in the right position. So at this point we know that's in the right place. I never have to compare against him again. When I go back to the next pass, so leave that turned over. So when I go to the next pass, I'm starting from the beginning again, and I now can imagine and pretend I've got an array of only size 3. I never need to compare those last two. So I look at this one and compare them. They're in the wrong order, so I swap them. I take the biggest value. Look at the next two. They're in the wrong order, so I swap them and I take the biggest with me and swap them back. And this time he's now in the right place because I've taken the biggest with me so far. I didn't need to compare him against any of the others because I already know they were in the right place. So he's now in the right place. And then when I do the last pass, I only have to do it as though I've got an array of size 2. So on each pass, I reduce the length of the array in essence that I'm sorting. I go one place less far. So this time I compare the two, and let's see what your values are. They're in the wrong order, so I'll swap them over again. And I don't need to go any further at all at this point, because now I've taken the biggest value with me. I know he's in the right place. But the thing is, if he's in the right place, he must be in the right place as well. This number can't be anywhere else. There's nowhere else for it to be. So once I've got 4 things in the right place in an array of size 5, I'm guaranteed that the 5th thing is in the right place. And that's why I know that I only need to do 1 less pass than the number of elements I've got in the array. Because on each pass I put 1 thing in its right place, and on the last pass there's nowhere else for the last thing to go. So 100 pieces of data on 99 passes, everything's in the right place, and the last one's got nowhere to go. It's got to be in the right place. So what we've just done is improve the algorithm. We've taken the basic version and of it doing multiple passes and realised we can actually do less each time because of what we know. We know that another value has landed in its right place. We don't have to do repeated work because it's not going to do anything. We don't need those comparisons. Okay, so let's see that improved algorithm in action. And there they're sorted order.